Hello, good morning, everyone. My name is Csanad Melegh, and I will hold my presentation in English if you don't mind. So, if you don't know, anyone don't know the Raiffeisen Informatik. It's an Austrian company, and we are responsible for the operation of IT applications of the Raiffeisen Bank, Lower Austria and Wien, and also operated the internet bank by us. So why is it important to know? Because the first thing I would like to introduce myself. I am in the last 25 years. I'm already in the finance IT. First, I started with the Raiffeisen Bank Hungary, which was a very good first time because from 1995, the company grows from 250 employees to 20,000. So this was a great experience. I was head of IT application operation, which is a very good position to hand over a lot of application from the development and keep them running and keep them up to date and keep them to response time at a good quality. So first I met with Dynatrace performance monitoring at the time. And in 2012, we had some performance issues on the environment, and I used Dynatrace at the time to solve these problems. From 2014, I moved to Raiffeisen Informatik Austria, and there I am in a position, I'm still in the position of lead expert of monitoring and automation, and I'm still focusing on the performance monitoring. And here comes the new challenge to me, which one is the monitoring of container-based microservice environments, which one is the internet bank application developed on. What size are we talking about on this internet bank? So it's a new style work dashboard-based internet bank solution. That means we have a lot of widgets on the screen, and these widgets directly calls microservices on the back end. So to solve and serve all these functionality on the internet bank, we are running actually more than 10,000 containers, and this is just the production system. So you have to imagine that on the development systems and the test environments, we also have such a size of containers, what we have to manage and monitor. These containers provide more than 3,000 services, which one also had to be monitored. This looks pretty impressive if I draw the Dynatrace functionality. The landscape looks amazing, so very, very hard to look through and find out what's going on here. So I like this screen, it's very impressive. If I try to explain someone what necessary to do when you are operating such an environment with a lot of container and thousands of services, this screen explains everything to everyone. Okay, what is the challenge? What we try to solve quickly when we started the Autonomous Cloud project. So in the Autonomous Cloud project, the main focus is to use and implement those functionalities which are available in the tools, and they are there, and sometimes simply we have to just use it. So actually the challenge, if in this size and this environment, we have a change or release deployment, we should know everything about it. So it's very important to make it traceable and visible very quickly and very easy if a new version of a container has been deployed, or even anything changed in the configuration and the versions of the running environments. How did we do, and how we do usual way this? So if you have for example, let's see this worst scenario. We have an issue with the performance of a service in the container. In this case, first you have to identify which container is this, what is the configuration item, what is the configuration ID of this container, what is the version of this container. You have to check, did anyone deploy anything in it? You have to open the tools, you have to search for it, and you have to check the change calendar, the release management tool, to see that, okay, even if something was deployed, what was that exactly? Check who accepted it. So you try to track back and trace back, okay, what exactly happened, what do we have to do, what is the plan to do. So this is a manual task, but how could that be faster? That was one of the challenge what we tried to solve with a actual solution. So what is this Dynatrace event API? Event API, what we have used. So the plan is that let's inform the monitoring system about the change and provide as much as possible informations about the change directly to the monitoring system, which will make it easier to trace back and track back the change to the source information. So this is a very schematic screen or chart about how normal usual deployment looks like. So what we have done, of course, release management, I didn't draw the continuity integration system and the boot system. Of course, we have them. So as I mentioned, this is a very schematic screen. So the release management tool informed the deployment tool about please deploy the next release and all the deployments necessary to be go live. In this case, we started two processes in parallel in the tool. One of them, of course, deploy the necessary changes to the target environment, start the containers. And as you know, the Dynatrace in this case, and this is what you see on the right side, I try to draw here. So after the container were created, Dynatrace automatically detected and create the service and the processes and the new processes in the monitoring environment. So this is because it takes some time. We have some delay. So we wait a little bit with deployment of event information because we have to attach to the relevant service and the relevant process and containers. So we have some delay. We wait for the start of the container, start of the service, while they register in the Dynatrace environment, and then we create the event where we inform the Dynatrace what is the background information, links of this change, what belongs. Okay, so this doesn't sound too complicated, and because Dynatrace has got this event API, which one receives this kind of informations, we were able to solve this. So where is the event what we created? So I inserted a screenshot from the environment where we have a GBoss standalone portal container, which one runs 11 services on the environment and running on the following hosts and the following container. You can see the brief informations, of course, and here appears on the right side all the the informations what could be relevant, like availability and so on. And here I see I have an event, and you can see the number of events in a quick chart, and that says I have one deployment, and here I can see in list all the deployments and the deployment informations. What is in this event? We put every very, very useful information to make quicker reachable. All the information was necessary for in any case of problems or just simply I want to know what's happened. So we put a Bitbucket direct link. So that's mean if you want to direct access the source of this container or this application, which one runs in this container, you just simply click on the link and you get directly to the source code. Component, the asset of the container is also available. You can check how it went through the deployment process itself. So that's mean if anything had changed or anything happened during the deployment process, who started it, when it was started, how it went through, what happened exactly. It could be interesting also during a problem analysis. This information directly on the click on the link will be available. The next one is the release informations. So you can directly click, the link is there. You do not have to search for a CI. You do not have to identify the CI ID and look after on several different systems. You just simply click there, and you are there. So the information is available for you. This is a kind of typical low-hanging fruit. So you do not have to do anything, not a system built for that to share this information. For example, for those operation guys who are operating the application on the IT operations side. So you do not have to create workaround systems. You just simply put the information there where the users, another users, the operation team used to work. This is the monitoring system. And they do not have to open different tools, align different kind of IDs and make searches. So directly access. So easy, easy. It's not so complicated. Of course, later this level of information on this kind of informations can be increased. So anytime you can add more information via the project name, version number, source of deployment, time, and just an entity ID. But later, of course, we can expand this information with any relevant links, which one can be interesting for us. How, this is also an explanation, is it really complicated to insert this event? This is just small technical background to that. Not so hard, just simple. You can say that what type of monitoring component do I want to give this or register this event? Then I have to choose the application, and then I add the Kubernetes namespace identifier, and that's all. After this, I will able to all the process group instances, the container representation of the in Dynatrace, and it's automatically all the events will be added, all of the instances, and it will be visible. If you do not have a tag, which one is necessary for you, no problem. The Kubernetes namespace is not a standard tag. We created and with an auto tagging rule. So if you need additional more information or more data to make a filter much more accurate, it's also solvable. So, and all of them is automatically. So not so much manual work is necessary to do. Typical low-hanging fruit. That was the first quick win on the autonomous cloud, what I think we made much more faster the root cause analysis and to reach more relevant data during the operation. Thank you.